All right, everyone, welcome to part 2. I have Rick here from Austin Microphones. If you have not seen the part 1 video, please check that out. I'll have a card on the screen or I'll have a link in the description. I'll have both. I'll definitely have both. It's not an or kind of situation. For the last video, we talked about some of the skills that you need to be working on gear, repairing gear, building gear.
Some of the education, maybe.
Some of the education stuff. We talked about ribbon mics a little bit. We talked about a lot of good stuff. But now with this video, what we're going to do is we're going to dig into some of the goodies that Rick brought along.
Yeah.
Right?
So you'll know from the last video, I make do-it-yourself kits for colleges and individuals, and we do workshops at those places. And one of the workshops we do, it started with ribbon microphones. So we run workshops and we build ribbon microphones. And I have a few. I don't know how much you can see from over there, but I'll just show you one. This one's red. You can hold that one.
Awesome.
And they
I'll get some B-roll too.
Yeah.
Should we just keep talking like this and then get B-roll?
Yeah, we'll just pretend we're talking into these unhooked up microphones. So these are ribbon microphones, and it really started with me. I was looking to record a guy who wanted to do a spoken word CD for his chiropractic office, and I was a patient of his, and he's like, "Hey, can you help me record this?"
Cool.
So I was in Austin at the time, and I said, what are some entry-level ribbon mics? Because he had a nice deep voice, and that's generally good with ribbon mics. And so I looked at some entry-level ribbon microphones, and they were all from Asia. And I found a group that was buying those and then gutting the inside, and they were showing pictures of the insides. And I'm like, that's simple. I could probably make that. So
were they modding the microphone?
They were taking out everything. They were taking out the magnets. They were taking out the ribbon. They were taking out the transformer. Okay. Right. They were changing the XLR to a switchcraft instead of the Asian Chinese one that doesn't always fit.
Yeah.
So I looked at all those things visually 17 years ago, and I said, I could probably make one of those. Rather than buying one, I'm like, I could probably make one. So I started building one, and I went to Home Depot, and I went to an art store and bought some foil, and I bought some stuff at Home Depot like that. And I ended up having a guy with a machine shop cut me a body that looked something like this, or maybe I hacksawed the first body. I don't remember.
Okay.
And I put it together, and it sounded good. Nice. And so then I sent it out to a guy to get it characterized, and it came back this razor flat ribbon mic, and I'm like, oh, I think I have something here. So I posted all the plans. I was an instructional designer by career at that time, and I posted the plans that I had written, wrote some plans, made another one, photographed everything, and then put it out on the internet. And in the first week, it was on Gearspace, which had a different name back then.
Yep.
That got downloaded 300 times in the first week, and I'm like, I got something here. So I closed the free download, and I started charging $10 for it, and it's still hundreds of people downloaded it. Yeah. And I'm like, I got something here, and they were like, where can I get all these parts? You know, I wish you had a list of all these parts. So I made a list, and I started making kits. And then like I said, I had a friend who had a machine shop, and he started milling these bodies for me, and it sort of went from there. But
that's cool.
We build these at workshops. And so in a day, you can walk in with your lunch and nothing else, and we bring all the tools, and you cut your own ribbon foil, you bond the magnets to the structure, you wire the transformer and wire all the stuff around there.
That's
it's
so
super cool. Yeah. So we, and I don't know if you probably can't tell, but you can, I don't know but you can see. Yeah, you can hold it up and see that you probably from the back. You can look online there. The thing that I brought. The thing I brought to the game was those little semicircular holes behind the magnets. I don't know if you can see those.
Maybe we can get some in B-roll after this.
It allows the sound to get to the back of the microphone quicker, so you get a better high frequency response. Right?
Yeah, and you were talking about that in the last video. That's so cool.
So so that I brought that to the game, and they're made of some stuff that's they're made of plastic or acrylic or polycarbonate at this point.
Okay.
And that's less expensive than getting a piece of metal machined. Yeah. So I'm able to provide something that's affordable. And I have a transformer that's made for me still in Texas, made in Dallas, I think. Okay. And I try to keep USA parts and all that stuff. Cool. Trying to support local vendors and things.
Nice.
So, yeah.
Is this the year that it was made?
I just so this one has light foil. Sorry, we're looking at some stuff on the bottom. that I've written. This has light foil,
Uh-huh.
1119. So I guess that means I made it in 2019 of November. Is that what does
Okay,
that say?
that's what I was wondering.
1119. Yeah,
Same
light
thing,
foil. And then let's see what this one says. There's
Yeah.
a third one. That doesn't say
Nothing.
anything, and so it's probably roughly the same.
Oh, this
I
one
think
has some cool texture on it.
Yeah, so the same guy who mills the bodies has a powder coat shop.
Okay.
And so local guy in Lakeside, if you're familiar with
cool.
San Diego,
Yeah.
has an industrial shop in Lakeside and has become my friend and mills my body and packages some of my parts for me. And
That's
so
so
it's a little
cool.
job shop, right? And so the money that a student spends when they buy this goes partially to my family and partially to this guy's family, and
Nice.
I don't have stockholders or anything like that.
Yeah,
you know?
yeah.
It's a family business. So
Nice.
yeah, so you can get them powder coated in whatever color you want, and
Yeah, I'll give you this one back
thanks.
too.
So so ribbon mics is one of the things that I make, and actually you can make them. I try to avoid making them because I have other things to do.
You set up the process.
I set up the process, yeah. So,
Do you ever this is kind of a sidetrack, but like I noticed I read this book recently, and then I've noticed a little bit from like opening up equipment that a lot of old like effects units and old equipment has like the serial numbers on the IC chips, like what's the word? Not sawn off, but filed off.
Filed off, yeah.
Yeah. Do
Yeah.
you see that with like a lot of? I assume you've taken apart microphones.
Yeah, yes,
I don't
I
actually
have.
know if you do that.
Yeah, I only because I'm interested.
Yeah.
Right, and I have built the confidence up. I mean, we should have talked about this in the first video. I have the confidence to take things apart and not feel like I'm going to screw it up. Although
Right.
I've done that.
Yeah.
Right.
I've done that too.
Yeah, I used to work at an audio place where we would scratch off all the numbers on
Wow.
there. Yeah.
Yeah.
And so that people wouldn't steal it.
Yeah,
Right.
yeah.
This technology is so old. It's from the 20s and 30s. All the patents they're expired, and you can make a ribbon mic out of whatever you want now. And
Yeah.
you don't have to pay anybody.
Yeah.
There are some new patents, like Royer has some patents about being an offset in the magnet gap, so it sounds different from the front than the back.
Oh, cool.
Yeah. So, and there are some other super clever patents about ribbon mics that are out there. But I don't scratch off the numbers, and I want people to know what's in it. We'll talk about that when we get to the guitar pedals here in a second. I want people to know what the TLO 72 chip sounds like versus a 1458 or a 386 or whatever the numbers are, right?
Yeah.
So, but I have encountered that in my travels occasionally. Or goop. You've seen it, pedals that have like black glue that they put all over.
Oh, yeah.
So that you can't pry stuff off,
Yeah.
right?
It's gross.
Yeah. Well, it's just so that when you try and break it off, you break off all the other components, and then you end up with a thing that doesn't work.
Right.
The Klon overdrive pedal was famous for that, and
Okay.
then somebody figured it out, and now somebody's posted that circuit online, and there's thousands
Yeah, it's like
of
people figure it out
clones.
eventually.
Yeah.
Anyway.
Yeah.
Yeah.
So make as many. I've had two patent attorneys tell me, make as many as you can before the Chinese rip it off.
Okay.
And I'll show you an example of that coming up here too. I got something that has been already ripped off by the Chinese that I came up with. Yeah.
Oh, that's cool.
Kind of
Like,
cool.
kind of
I should be
flattering,
flattered.
right?
Yeah.
Yeah.
Right. Yeah. So.
I mean, I'm sorry.
Yeah,
but
no, it's
also
all right. It's all right. And
kinda cool.
it hasn't hit the market. We'll
Okay.
check it out.
Yeah.
All right. So I make ribbon mics. That's one of the things.
Mm-hmm.
And I also have a stereo ribbon mic. Go check out her video on Bloomland technique.
Oh, thanks.
That's pretty good. It tells you about what to do. But I make a ribbon mic that is all in one. You don't have to set it up. It's just you just hook it up, and it's already
Nice.
set up in the XY pattern.
Cool.
And they're coincident. They're as close as they can possibly be,
Mm-hmm.
and you don't have to worry about it. And so I have a
Nice.
Bloomland kit that comes
That's so
out.
cool.
All right, so we also do guitar pedals, and so this is just the standard look of it. I just even on Monday.
Should I move the camera?
No, it's fine.
Okay.
It's fine. On
B-roll too.
Friday, I designed another graphic, and so I'm going to have another graphic that's going to look like a surfboard like
Okay.
this.
Cool.
So other than this checkerboard pattern, but
I like the checkerboard.
I used to have on the bottom, the bottom plate. Where's the bottom plate? Anyway, I used to have the Vans waffle pattern on the bottom,
cool.
so it looked like Vans shoes.
Yeah,
but that
yeah.
just cost too much money, and
That's fun.
I'm trying to make them student affordable.
Yeah.
So, anyway,
That goal.
we designed this pedal to not just be a pedal that you just build and it sounds one way and you're done with it and everybody's pedal sounds the same. you can't quite tell. Maybe you'll do a close up or something like that.
Do
But
some B-roll and throw it on the screen.
There's sockets that you put the tone components in. You can change diodes and you can change resistors and capacitors, and you can actually, and even the actual amplifier chip that's in there as well. Mm-hmm. And the whole point was, if you're building a pedal, why not learn what those things do?
Yeah.
Right? So on my instructions, it tells you what to do. And then in a different, in a different font and a different color, it tells you what that part does.
Yeah.
Like this sets up the bias voltage, and this one stops the signal from getting to the next stage or amplifies the signal or whatever.
Yeah.
So it's actually a sort of a springboard into design or modification or even repair, right?
Yeah.
So part of that education that we talked about in the last video is doing stuff.
Yeah.
Right?
Yeah.
Just getting in there and just working on it. So,
and I love this. This is what he had at that workshop that we mentioned, I think, in the last video. But the socket thing is so interesting to me because, like, previously I've just worked with, actual soldering, and it's really cool. You can just pull them out and stick them in and experiment. And, yeah.
And that's the whole point, because if you listen to your pedal and you're like, I don't like the way this sounds.
Yeah.
If you just built the pedal and that's the way it was, you'd be like, oh, disappointed. I just spent all day building this and it sucks.
Yeah.
But with this, you can go, I'm just going to pop that tone component out.
Yeah.
I want to change it. I want more metal, or I want more blues, or I want less treble, or I want more mid-range, right? You can do all that stuff with this pedal. So,
and you had like a handout, right? Can we talk about the handout, like with actual information? Because I think that's so cool.
So this was at the class. I don't know. You can post it, but tone shaping components.
Yeah.
It gives you a little chart about what to do.
I'll hold it up.
I call that the ARG chart because it ends up saying ARG at the top about.
Ta-da.
Yeah,
I'll take a better photo.
Yeah, no, it's fine. It just tells you here's where you want to have these parts for this particular stage of the amplifier.
Yeah.
You want more drive or less drive, or you want it to be like too much drive, and then it'll tell you what diodes to use to get these certain sounds. Mid-rangey, or a lot of clipping, or less clipping, or smooth clipping, or hard clipping. And then capacitors to roll the frequency response off or change the frequency response.
Yeah.
They say tailor the high end response.
Yeah.
So it can be like a fuzz pedal that has, basically no high end, and it could be a nice, mid-rangey tube screamer type guitar pedal. This might not be super interesting to non-guitar players, but it turns out that everything has these components in it.
Yeah.
Your synthesizer, your preamp for this microphone has these components in it. And if you're at least aware of those things, you're going to be more likely to get in there and just like take a look.
Yeah.
So. And
I love that you're sharing this information, because sometimes it can be kind of, people sometimes don't want to share it.
Yeah.
But it's so cool. Like here you just have, it says like, if you want more or harder distortion, lower value resistors, right?
Yeah. Yeah. Bam. Or if you want smoother distortion, use these diodes instead of those diodes.
Yeah.
Right? So, yeah, it's cool. all fun. I mean, and the other thing, these are free on my website. You can go and download the entire set of plans. You can download the entire. It shows you the schematic. It shows you everything. I want you to build this thing. It's easier when you have a kit.
Yeah.
But you can. Buy the parts and make your own if you want. So, it's kind of neat. So, my whole thing is educating, new generation of people who want to, or like, wow, that's kind of cool. I don't have to go and buy this on Amazon. I can make one.
Yeah.
Or I can buy a kit of parts on Amazon and make 10.
Yeah.
So
I love it.
Yeah, it's pretty awesome.
It's like sharing the enthusiasm too.
It is. You can tell I have a lot of enthusiasm towards education.
It's contagious. So, I love
it. Good. All right, so let's jump out of actual electronic products for a second, and I'll show you something that I invented.
Okay,
right?
cool.
So this you can hold this one. This is
called
this is called the hot holder.
Oh, I remember this from your workshop.
Yeah,
I love it. I'm gonna get one.
Yeah, this is it's a block of silicone, and it's molded with different voids essentially for different things. So the one you're holding is got XLR, it's got 1/4 inch, it's got RCA, and it grips this thing. And the big benefit here is that silicone, this high temperature silicone, is not a heat sink. It doesn't suck the heat out of your work like those little alligator clips. And it sits flat. I don't have a flat surface. It sits on your bench and it won't move around when you're doing stuff. You're probably shaking the camera when I'm doing that. But it sticks. And if you have a circuit board, this one has a circuit board slot. You can put a circuit board in, and it's in the perfect angle for soldering. So anyway,
because I'm always like,
you're chasing things around the bench.
Trying to hold like two things at once with the wire.
Or vice grips, and you're smashing, holding things, and you're holding them too tight, and you're like, oh crap, I just bent that, right? Yeah. So these are silicone, and you can't really scratch or bend anything in these things. So anyway,
these are so cool. Are these 3D printed?
They are not. They are. Really? They're a combination. I don't want to give away exactly what I'm doing because, like we talked about before we started shooting, this has already been ripped off by.
This is the thing.
This is the thing, yes, by an Asian company, yes. So it was interesting. I saw it at the NAMM show, and I'm like, "What is that thing?" Knowing full well exactly what it was, and they're like, "Oh, we use these to make cables at our shop." And I'm like, well, what does that little square void do? What is that for? And they're like, oh, it just holds things differently. Or what's that oval? And they had copied the actual visual.
Was it the same exact layout?
Not the same exact layout, but the same exact shapes. But they didn't know what those shapes did or how deep they are or what undercuts they have or anything like that. They had just visually copied it.
It's kind of a giveaway.
Yeah.
Wow.
Yeah. And they were like, oh, yeah, we're not going to make this. This is just for us. And I'm like, well, you sure spent a lot of time making that one.
Yeah.
So anyway, so that happened. I should be flattered. I am a little bit flattered that, it's going to happen. Like I said, the patent attorneys just told me to make as many as you can before the Chinese rip it off because they can just change one thing about this and then my patent doesn't work. So,
right. Yeah.
So, all good. And so that's the thing that's been ripped off by other companies. Yeah. And I should be flattered, right? I should be.
Yeah.
So.
Well, if you want the good ones. Seems like
these are the originals. They will always be the original hot holders, right? And they will always be this color as long as this color exists in the high temperature silicone.
I like the color.
Yeah, and so these are also made by that job shop that I'm supporting with my his family and my family. So
nice.
All made in San Diego.
They're kind of fun to
USA.
hold too.
Yeah, they're kind of neat, huh?
I'm like,
So yeah, that's a parts holder, really.
Yeah, that's cool.
Kind of neat. And let's see, what else do I got? I got a tube. This is actually a tube amplifier, but this one is for a spring reverb tank. So again, a kit that you can get from my website. I'm not the only one making kits. You can buy kits from anywhere else. This is not a commercial. But you would get in there and you would solder up all these components according to instructions, just like those guitar pedals we talked about a second ago. Put these capacitors across these two things and run this red wire from this component. I keep hitting this mic. Run this red wire from this component to this component, and then it tells you what that's doing, what that red wire is doing, and what that orange capacitor is doing, and what the yellow capacitor is doing.
So it's not just like instructions on how to do it; it's actually educating you about what the thing's doing.
It'll tell you like here's where the and then I have videos that show you. They talk about the circuit. You should check those out. I'll send them to you.
Yeah,
you'll be. I would imagine you would be like, oh, that's it. That's all that a vacuum tube does. It's so simple. And so you get to learn about vacuum tubes and the circuit and stuff.
Cool.
So this is a reverb, and then I have an amplifier that's very similar. In fact, the same case and everything. I just make an amplifier out of it, and it's a little small combo amp. And again, you can build that. But the thing here is doing. We talked about this already. Get out and do this stuff. And I know there's some expense. Yeah, tube amps are a little more expensive than a pedal.
Yeah.
But start with a pedal, right?
Yeah.
And then start with go to a better pedal, and then build a microphone or build a clone of some microphone. And then work up, and then you build your confidence, and you stop being afraid of what's inside the box, right? You know, so
starts to make sense.
Yeah,
and then you can mod stuff if you want. Once
you can, and then you can repair your friend's equipment. You can be like, oh, I'm not afraid of that. Let's go fix that. Let's see what's in there.
I've done that. I repaired a soundboard for a friend a while back, and there was a moment where I was like, I'm not going to be able to get this whole thing back together because it was like. It was not made to be taken apart.
Right.
I was like, oh no. But I did
there's some stuff like that. Everything was fine. Yeah, but you have the confidence.
Yeah.
Yeah, and you're like, oh my God, I just did that.
Yeah.
I recapped an audiophile amplifier that another shop in town refused to look at because they're like, we don't know anything about this amplifier.
Right.
And so my friend who's a mastering engineer, he just came to me and is like, listen, I'm at my last wit's end.
Right.
I'm gonna
buy. It's broken anyway.
I'm gonna buy another one. Let's look at it. And I opened it up, and I had the confidence to unscrew all the things and unhook all the cables and unsolder the capacitors and put new ones in.
Yeah.
And the things work. And now he has, $5,000 audiophile mastering amplifiers back again.
Nice.
So I feel, and we spent like $300 on parts, which sounds like a lot, but $5,000 mastering amplifier, it's 5%, 10%.
That's the cheaper option.
It was. And those are the ones he wanted, right? So he didn't have to go out and buy something again. So that was pretty awesome.
Nice. Are there, what like safety considerations should people?
Oh, okay. So so there is safety, especially with vacuum tube equipment. There's super high voltages that can kill you.
Yeah.
They will shock you, and I know that. I actually got shocked on my wedding ring one time, right through. There was a stray wire, and I got shocked through my wedding ring, and it zapped me. But yeah, in fact, on this tube amp and this spring reverb that I make, I invented a low voltage adapter, and you go and you test. You don't plug it right into the wall. You plug it into a 9-volt power source, and then you test these voltages at low voltage, so like 20 or 30 volts. And if something doesn't work, it won't smoke the components. It won't burn your fuse every time. You're not going to shoot sparks out of it if it doesn't work. A little light will come on and say, you have a huge problem here. And then you have to go find that. But it won't burn your house down. It won't kill you if I don't know. You might have a different electrical conductivity than me. Can't say it won't kill you, but it is unlikely to kill you at 30 volts instead of 300 volts. You're working at a tenth of the voltage. You don't have to be a master electrician to do it. I walk you through all the, test this voltage here, test this voltage here.
Cool.
And there are safety concerns. I think about it all the time. It sucks to get shocked.
Yeah.
It would probably suck worse to get shocked where you don't remember it, but when you're testing at low voltage and you're inspecting and you're like, okay, that voltage is correct and that one's correct and everything is correct. At that point, when you plug it in, it should all work.
Yeah.
So, and it all should work at high voltage. So,
yeah.
So there's safety concerns. Also, lead solder can be an issue, or even lead-free solder can have some other issues.
Yeah.
I don't know if we talked about that at the workshop. We didn't do any soldering.
I don't think so. No.
Yeah. So the difference between lead-free and leaded solder is lead is bad for your hands or your skin and your body, but you can go to the restroom and wash it off. And the flux that's in a lead solder is a tree rosin, it's like violin bow rosin. It's natural, right? And it smokes, and that's probably not great for you. But the rosin that's in leaded solder is a chemical, and that when you breathe that in, you can't go to the restroom and unbreathe that, right? And it's in your body. So at my workshops, I give people the option to use lead-free solder, but almost everybody uses leaded solder because you can wash that off. So there's some of those safety concerns. And then we always have safety glasses because when you cut legs of things off, somebody won't hold it and it'll shoot across the room. Yeah. So there's a lot of safety, electricity and eye protection and hearing protection if you're going to do loud amplifiers and stuff. So all that stuff is a big deal.
Do you use leaded solder?
I use leaded solder, but I wash my hands, and I've been using it forever. Yeah. Before there was lead-free solder on rolls. Yeah, I worked at an audio place where I did amplifiers for drive-thrus. Nice. So the little headphone amplifiers.
Yeah, that's so cool.
Yeah, and it works better. Leaded solder, it's just easier to work with as a human being. Robots can do lead-free solder easy. Yeah. But humans, it just takes a different skill set.
Okay.
So,
I'm using leaded too, but I think about that a lot. How I'm like, I probably should switch to unleaded. Should I switch to unleaded? Yeah. I don't know. I'm like, I'm breathing it, and I'm like,
well, it's interesting. There's not much, if any, lead in the smoke. Oh. It's all the rosin.
Okay.
The lead stays in there. I mean, quote me if I'm wrong, there might be some lead, but it doesn't seem like there's enough.
Okay.
But
I know lead doesn't leave your body, right? It's one of the things that your body doesn't cleanse out.
So if it's on your skin,
naturally,
you can wash it off. And you're right. If it's in your lungs,
once you breathe it, it's there.
Yeah. Once that, or the chemical from the non-leaded, the unleaded solder that's there. Yeah. So there's safety concerns. It's a trade-off. Yeah. Right. There's good points and bad points. You still got to solder it. you're going to either be exposed to fumes. And some of the workshops that we do are outside. They're under under pop-up tents or whatever. And so there's natural breeze, and we have fans and stuff like that run through. Okay. And so we're conscious of it.
Yeah.
And I have a workshop that I have open windows in, and I make sure that I have a fan that blows stuff away.
Yeah.
So
cool.
Yeah. Good point. Yeah.
I mean, like, I'm still doing it, but I think about it sometimes.
Yeah. Ask me in 30 years, right?
Yeah.
If I can even remember. No, I'm kidding. I pay attention to it.
Yeah.
I was in that industry for a long time. And before you go to lunch, you wash your hands, right? And before you itch your eye, you wash your hands so that it doesn't stay in there.
To?
Yeah. You try to. Yeah, you do your best, right?
Try.
This is completely off topic what I'm going to say. It was more dangerous for me to drive here today than all the lead exposure that I've had in my lifetime, right? So
that makes sense.
Yeah.
So,
all good. Do you want to do? We're going to do the thing that I brought that I told you I was bringing.
Yeah, let's do it.
Right. So I make ribbon mics, and I've become friends with Dave Royer over the last 15 years.
So cool.
And Dave comes to some of my workshops, and he'll provide color commentary and say that looks good, and help. Hey, maybe you should cut that ribbon a little thinner, or those corrugations aren't stretched tight enough, or whatever. He'll help out. And so he wanted to do a workshop for condenser microphones, and he's a tube guy, and he wanted a tube condenser. And we were gonna, this is pre-pandemic, just barely pre-pandemic, we were gonna do a tube mic workshop for a college in LA that's dedicated to people who are on the autism spectrum.
Cool.
And the intention was we needed something that people could do that didn't require tons of focus, and we could do it. So we came up with this design. Dave designed the power supply, and I designed the microphone. And this is the prototype of that microphone. And I'll tell you why that's important here in just a minute. So here's, I don't know what you can see with that GoPro, but here's the power supply that Dave designed.
Cool.
So I think I might have built that one, but it's definitely Dave Royer's circuit. And you can tell on the back it's got an extra hole where I just screwed something up. So all it is a power supply. It supplies the right voltage for the tube in the microphone.
Cool.
And then the microphone that I ended up designing, this is the prototype. This ended up being the first microphone that we made, the proof of concept. I don't know if you can see that. Here, go ahead and hold
I can get the B-roll too for it.
And it turns out that screw in the front was my mistake. I forgot to put a ground on it, so I actually ran a little ground wire up and grounded it. Yeah,
that's
grounded
cool.
it to the windscreen.
And that doesn't mess with the sound too much? To have that, like,
I don't think so. I would like to think not. Yeah.
Yeah.
I mean, there's another wire that goes right to the capsule, right, in a condenser microphone. So it's probably okay.
Right into the middle, right?
So we were out testing this microphone and a couple others that we had made as prototypes in Dave's Mojave cabin in Joshua Tree. And his marketing manager was there at the time. And he's like, Dave, how come Mojave Audio is not making one of these?
Yeah.
And he's like, I don't know. We probably could. And then the pandemic shut down our workshop for the school in LA. And Mojave picked this design and started making them. And now this is the prototype of the MA37, which is a fairly pricey microphone, and it's a copy of the Sony C37.
Yeah.
So, but what you're holding in your hand is the very first one, and the one that said, "This sounds great. How come we're not making one?" You know. And so this is a bit of history for that microphone.
That's so cool.
Yeah.
Did you make like a shock mount for it?
I didn't make a shock mount, but I have a 3D printable shock mount you can download from my website. Yeah, and you just jam it.
That's 3D printed?
Yeah, jam it through there. I mean, it's got hair ties as the thing. So
I've done that. I've used hair ties.
Yeah. These are silicone hair ties, so it doesn't slip. But
nice.
You just jam it up inside there.
That's
and
cool.
And that again.
That's so great.
I
didn't realize that was 3D printed.
Yeah.
Now I see it.
It seems obvious right now, but it seems an obvious good thing for a 3D printer to be able to do that. So
cool.
Again, free on my website if you want to download those plans
to
print that or the file. So anyway,
Should I give you this back?
yeah, sure. I mean, you could try it out. I mean, if you want it.
Just
sounds
keep
fine.
it?
Yeah. No,
Keep
you
it. Cool.
don't get to keep it.
Thanks.
So
I'll keep it forever.
I barely got to keep it. It's in a box that came back from Mojave. It's got
Oh, yeah.
Mojave's return
They were
address.
like, we might need to keep this.
Well, they wanted to photograph it is what they wanted to do.
Oh,
They wanted to show that here's the progression. And so I think they ended up photographing it, but I don't know if they ever put it out in any marketing material.
Okay.
Dave wanted to get, there's some other microphones that are green and silver and stuff like that we iterated along the way.
Cool.
But this is the very first one, and Dave's like, well, that sounds good.
Yeah. That's cool.
Yeah, so always
That's so
good.
cool.
Yeah.
I would brag about that forever.
It's pretty awesome, and I'm not saying that I designed the MA37. That's not what I'm saying. I have a little bit of street cred from being in that room and making sure everything sounded good.
That's
but
cool.
Yeah, Mojave and Dave Roy are the owners of the MA37. I'm not that guy. So
it's still cool.
It's all good. Yeah.
Yeah.
So
It's still cool.
All right. I think that's all the cool stuff I brought. I mean, if you want
your toolkit, right?
Oh yeah.
Can we nerd out about the toolkit?
We can nerd out about Toolkit. So I've just found this.
Cool.
Just found this DigiKey. If you're familiar with DigiKey, and you will be if you start building stuff. DigiKey is a U.S. distributor of electronic parts, resistors and capacitors and transformers and everything like that. This is new, and I'm not a shill for them. I just found this. And they want, I think they want like at, what is it, 2024? They want $100 for this toolkit, but it comes with everything. And I don't know what you can see here, but it's got a meter, it's got a soldering iron, it's got a solder sucker, it's got lead-free solder.
Okay.
It's got solder wick, which helps you remove solder when you need it.
Yeah.
It's got the probes and everything, and some hand tools, a wire stripper. And all these screwdrivers, like this is perfect for your first, like my little toolkit. You know?
Because I have like my little toolkit, like my first toolkit.
Yeah.
It is, I mean, I'm like at the beginning of this journey, but like it's a tray and then a bunch of stuff just like loose in the tray.
Oh, awesome.
And it's like not this organized.
Yeah, no, this is, my tools aren't disorganized.
Yeah.
And there are some things that we can't build ribbon mics with just this. We need a couple other things, but this is literally 90% of what you would need to build any. I think we could actually build guitar pedals with this kit.
Oh, cool.
And at my next workshop, I'm going to bring this kit.
Yeah.
And I'm going to build one. I'm going to build along with the students, and
cool.
We'll just build
See
that.
how it goes.
Yeah. So DigiKey
great.
has this, and again, I'm not advertising, but there's the part number. You can choose to go there if you can.
Cool.
Read that.
I'll get some.
So
B-roll.
okay.
You said that soldering tends to be the biggest issue that pops up. What do you tend to see with people like newbies?
A lot of my students are first-time solderers.
Yeah.
They love the pedals. They love the microphones. They've used microphones. They've used guitar pedals.
Yeah.
Right? They've used amplifiers, right? And they're confident enough that they feel like they can build one, right?
Yeah.
And that's the goal. You walk away. Nobody leaves my workshops with things that don't work, right? So part of that skill... Part of that skill is learning how to solder.
Yeah.
And at my guitar pedal workshops, I do a little prerequisite where I have this little circuit board that has 7 solder points on it, and it makes this little LED flash and come on, right?
Okay, cool.
And that's sort of like your prerequisite. And I know if you follow the instructions and you solder everything, and I have a little, soldering spiel that I give about holding the iron on there and all that stuff. But I know that at the end of that little 7-point solder thing, if your LED light comes on and it does the thing it's supposed to do, I know that you have the confidence, and that student also realizes, holy crap, I just soldered that thing, right?
Like
and
you
then
passed the test.
Yeah. And then the very first step in our pedal kit is soldering all of those sockets that we talked about. And each one of those sockets has 8 pins on them. And there's 4 sockets. So 32 of the exact same solder points over and over again. So we're working up and we're trying to solder. However, everybody's doing this, or not everybody, a lot of people are doing this for the first time. And sometimes that does present a problem. There's solder bridges between the pins.
Yeah.
Or there's not enough solder, or somebody doesn't have the right magnification for their eyes and they miss 1 or 2 components.
Okay.
The benefit of coming to a workshop is that I generally know what pitfalls we're going to run into.
Yeah.
And I can go, okay, well, if you don't have any sound, but we have this light on, there's only so many things, right?
Yeah.
And we can go and inspect those things. Doing it at your home, I do have a troubleshooting. So the very last page of this document is a troubleshooting document. And it says, hey, if you don't have any sound, try these things. If you don't have your LEDs not coming on, or if it works when it's off, but it doesn't work when it's on, you can try these things, right?
Yeah.
So I've tried to figure all those things out.
Cool.
And again, give you some ideas about and even plugging it in the correct way, right? That I've made that mistake. You know, troubleshooting is another step, and that comes a lot with experience and understanding the mechanics of soldering and the signal flow. Oh my God, I want to tell you about this thing we're going to do at City College. And this is on the docket. We're thinking about doing this. In the scope of talking about soldering being a problem, it turns out that cables and microphones and connections and snakes and all this stuff, that turns out to be a real problem in a real recording studio, real world problems. So what we're going to do is myself and some of the other instructors are going to set up this studio and bug it. We're going to put a bunch of bugs in the studio, and then when the students come in to take their class, they may not know that there's going to be a sudden they're going to throw them in the deep end. We're just going to pretend, hey, there's this band that's here recording and there's all these problems we got to fix, right?
Fix the setup.
Fix the setup, right? And, hey, we're not getting sound out of this microphone, but, it's not because it's a bad microphone. It's because the snake is plugged into the wrong channel, or I have it muted on the console or whatever. And then so that will give students real world experience about troubleshooting, which we talked about a minute ago. About troubleshooting those problems and real world problems and putting that into your brain and remembering, oh my God, I did that in school one time and it was the channel insert was in the wrong thing, or I had a bad microphone cable, or there was this buzz and I remember we fixed it this way, right? With a DI or something like that, right?
Yeah, perfect.
So that's going to be super fun.
That's great. Yeah. I love that because I feel like a lot of schools don't teach troubleshooting in that way for the studio stuff. Like it's
when you are going to that job where you want to get a job at a studio, your first job is not going to be mixing the Grammy-winning artist on the mixing console. It's going to be fixing the cables. It's going to be troubleshooting why this mic doesn't work, or why this snake channel doesn't work, or what's going on with this, and all that stuff is huge for somebody who's wanting to hire you. If you can do all that stuff, or have done it, or did a troubleshooting class where we had to unbug a studio, that's going to be huge for you when you
because they want to send you into the room to deal with checking the snake and
or they can send you in after hours after the talent has gone, right? And you can do it from 2 o'clock to 4 o'clock in the morning. So which is exactly what happens, right? So at a studio they're always running. So getting that talent in and out and getting it working and getting the problems fixed super fast is exactly what they want. So,
I love that. That's so great.
So that should be a fun class. I can't wait to do that.
That should be fun to watch.
It's gonna be fun to set up.
It's like, oh, let's cause trouble here.
Yeah, exactly. Right.
It's got to be a good way to learn signal flow too. Thinking about learning how to think about that, like from the start to the.
Yeah, you could even say this microphone sounds horrible, right? And it just could be a gain staging issue, right? So it could be all that stuff.
That's so cool.
Sounds fun.
I want to come watch that.
I will let you know.
Thank you.
Okay.
Cool.
All right.
Is that it?
I think that's it. Yeah.
Cool.
Yeah. Get out there and do stuff.
Yeah.
If you've made it to this far in the video, you are one of us.
Yeah.
We should.
And thanks.
Yeah. Thanks for making it to the end of the video, right? Watch all of the rest of the videos. Go to my website, download some stuff.
What's
check
your website?
it out. www. Do you have to say that anymore?
I don't think so.
AustinMics.com, MICS, or DIYRibbonmic.com.
Cool.
MIC.
I'll put it all on the screen and then in the description too.
Yeah, and I'm not the only one out there. There's hundreds of places you can go and get kits and information and YouTube videos and stuff. So, do it.
Sweet. Cool.
All right.
Well, thank you.
Thank you.
And let's see. What do I have to say? Thanks for hanging out. Like, comment, subscribe, hit the notification bell. Thank you for hanging out.
Awesome.
This was really great. And I think that's it.
Bye.
I come out with new videos every Wednesday. Thanks. Okay. Okay. So we're gonna do.
We're talking about stuff, right?
Yeah, we're gonna talk about stuff.